Hey everyone,
Hey,
how are y'all doing?
Doing well. How are you?
Doing okay, doing okay.
How's your husband doing?
You know, he's like the little Energizer bunny. He just keeps going and going, but he did get transferred to rehab late last Friday. So he's in rehab and he must be doing better today because he's called me 3 times complaining. So
that's a good
Yes,
sign.
he's doing better.
That's a good sign.
like, well, you're in your wheelchair, go get your own. So he's doing better. So hopefully he'll be able to come home in about a week and we'll go from there. It's just been a crazy 2021. I think it's still 2020 at my house, actually.
Yeah, I get that.
Yeah, it's wow. It's been good, but yeah, he's making a great recovery despite everything that's happened. So we're blessed.
Do you have any ideas on how long he'll have to be there?
We'll know tomorrow. They do their staffing on Tuesday mornings. I'm thinking he'll probably, if he keeps making the progress he's making, he'll probably get to come home maybe next Monday or Tuesday.
That's good.
And
Wow.
he'll be able to, yeah, he'll be able to do most things for himself, because he's just really bounced back. And the type of stroke he had, it was a vestibular stroke, and those usually result in death. So the doctor told him
Wow.
today, said, it's just amazing you're even here. So that made him feel good. And yeah, so he's getting his function back, and just the heart's still so weak. That's the only thing that we'll just have to continue to deal with. But we'll take whatever happens.
That's all you can do, isn't it?
Yeah.
That's
There's
good
still-
though. Good report.
Yeah, it is. It's outlook looks better this week. Letting some more in here, and then we'll just get started. What I'm going to do tonight, I did pull the syllabus from the first class, and because I'm using Dr. Smith's syllabus and all of his assignments and everything, the bridge is there between the first class and this class. And the first couple of weeks, we're really just kind of looking back at that research process of, how to actually develop the research proposal, the concepts, the research questions, the null hypothesis, all of those things that go into play before you actually start collecting data. So that was week 1. Week 2, week 3 is this week. I can't believe it's already week 3. So this week, and then this week is when we will begin looking at what you do after you collect your data. So the things that you do before you start collecting your data, obviously, is laying out your game plan for your research proposal. You have the concept. You have to delve into that literature, the big literature review. Look at what we already know about the topic that you're interested in, the other research, what it says. From there, you develop your overarching research question, and then you figure out your hypothesis. The hypothesis, the semantics are very important in the hypothesis and how you word those, because that's going to tell you how you're going to conduct your research, how you're going to actually design your data collection and what instruments you're going to use. So all of that comes into play. But then we're going to learn about how to analyze and the different statistical tests that are available based on the different models that you may use to collect data. You have to understand that part to go back and be able to do that proposal part. So it still all kind of ties together, even though it's kind of linear in how you develop it. So this week, it was set up to look at model assumptions, and I've expanded that to include how to clean up your data. So once you have your proposal, it's all approved, you know what you're going to do, you collect your data. So now you have all your data and you have to decide, oh my gosh, what do I do with all of this? The very first thing you have to do with data is you're going to have to clean up your data. And there's some assumptions, and then there's some just basic cleanup stuff that you're going to do. So I did send out the PowerPoint. It is not 100% completed yet, because I want to include screenshots from the SPSS on the different, like the scatter plots and the box plots that you'll use to test and clean up your data. And I don't have an SPSS license, and I haven't been able to get IT to get me the license yet. So hopefully they'll get it tomorrow. If they don't get it to me tomorrow, I'm just going to buy the same one y'all are using and then add those in there. But I explained I've used Excel for so long, I haven't used the SPSS license, and I didn't realize it had expired.
And they have if you have like a different email, they have a 30-day free trial.
Yeah. Yeah. So I'm hoping I can get it. I was actually up at 2:45 this morning, and I thought, oh, IT won't be busy. And I called them, and I was on hold for 45 minutes and hung up. I thought they're asleep. They're asleep. There's no way that they're that busy. But I have some behind the scenes people that hopefully if I get that tomorrow, then I can actually include those screenshots from SPSS so you'll know what to do. All right. But I'm going to share my screen. I'm going to attempt to share my screen so that I can just kind of go over the PowerPoint anyway as a, can y'all see that? Well, let me see if I can try again. Can you see my screen?
Yes, I can see it.
Yes.
Can you see the PowerPoint? Okay. I'm just going to briefly go through this because, again, I'll record it and you'll be able to go back to it later. But this will help me just hit the points. So ask questions because for some reason when I bring this up, I lose y'all. I can't see you guys. It may be because I'm using two different monitors here. But just let me know if you have questions, but I'm just going to briefly kind of go over this. And basically, there's some assumptions in statistics that you have to consider, but there's also just some cleaning up of your data. So once you've gathered all your data, this is going to be the first stage you're going to go through before you actually start running any statistical test. This can be pretty time consuming when you're going through it, but it's really important to do it up front and have clean data when you start running your tests, because then your results are going to be a lot more valid. Okay, so the first thing that you're going to want to look at is you just want to eyeball your data. If you have a smaller data set, it's easier to do because you can just look to see if there's any type of numbers that don't look right or categories that don't look right. If you have a larger data set, then you can actually use some descriptive statistics to run to see if your categories look okay. But you just kind of want to eyeball it to see that there's not any big discrepancies. There's not a lot of missing data, which you'll have to deal with, that type of thing. So you just kind of eyeball it to begin with. Then you can run some descriptive statistics. But the things you're looking for missing data. Missing data can present some problems when you do your analysis. You're going to look for outliers, and we'll talk about that. You're going to look for independence. You're going to look for normality, homogeneity, variance or homoscedasticity, and linearity. So these are some things that you're going to be looking for and analyzing your data before you ever begin to run your statistical analysis. And that first thing is, okay, again, you can run the descriptives and you can see what your ranges are of your different numbers. Are there any of the outliers there? Do the categories look okay? Again, just to kind of look at that and get that eyeball on it. if you have missing data, you have to make a decision about what to do with this. And sometimes it's not so much about missing the data, but it's about the patterns in the missing data. And I have a real world example of this, and back in my dissertation, and I think I've shared with y'all, I was looking at stress factors for individuals after they placed their loved ones in a nursing home. One of the demographic questions that I asked was annual income. And I had 116 individuals who completed the questionnaire, and out of that, there were probably 35%, I don't remember off the top of my head, that skipped annual income. So when I went back and looked at that, that's a lot of missing data, and there's a pattern there. And the pattern with that was because I was interviewing individuals who their loved ones were in a nursing home, and it's very possible that their loved ones were there and being covered under state Medicaid, and they didn't want to reveal annual income for fear that potentially Medicaid could be taken away or it could be used against them or something like that. So I had a pattern of missing data I had to deal with. Otherwise, my results could be compromised. What I decided to do was I had 4 different counties that I was collecting the data in. So I went to the census data and I got the median income for each of those counties, and I plugged that into my missing data. That helped me get the numbers that I needed for my averages, my median income, and things like that for my sample. And then I just explained what I did. So that way I didn't lose 30% of my participants because that data was missing. I had to recognize there was a pattern in that missing data, and I had to make a decision on what to do about it. So if you have missing data, if you have just a few here and there, it's not going to be a huge deal. But if you have systemic missing data, you have to decide what to do with that. The other one that you're going to want to look for is outliers, and those are those extreme cases. And because outliers will skew your mean, and many of the statistical formulas that we use that mean, like we talked about the ANOVA, the t-test, they all have to have that mean. So those outliers can skew your mean. And then this is just a brief example. So this is an example that I've used in my class before. And so let's say that university students are going to a conference and they're allowed to use university cars. And in the cars, there is regulators that collect speed limits, okay? So we collected speed limits of 16 different students for January, February, March, April, and came up with these averages here overall. But if you'll look here in April, there's an outlier. There's somebody who was going 150 miles an hour. Now that was pretty fast, right? So there's this outlier in April. So when we actually do the analysis, it's going to show that outlier is going to skew that. So the overall mean is going to be higher because that outlier is pulling that mean up. So I have to make a decision. What am I going to do about that outlier? Well, since I only have one in those 16, I'm just going to eliminate it. And I can't just eliminate, I have to eliminate the whole case. So I lose all the variables along there. But it's the best to do that in this situation, just eliminate it, because then it brings my mean back into it and it gives the true meaning of the data. When we have the outlier in there and we look at the mean, it looks like all the students, or the mean for all the students driving, that they were driving over the speed limit, when actually there was only one driving over the speed limit and everybody else was under the speed limit, but that outlier pulls it that way. So I had to go through that to make a decision about what to do. And by removing that outlier, then it gave me a better picture of what was going on. So you have to look for outliers and deal with those. You're going to look for independence of observations. And this is really for t-test, ANOVA. It's going to be for multiple regression, simple regression, because you want to make sure that there's not a dependence in terms of different variables. Otherwise, you're going to get results that are not going to be accurate. So the one example that I put here is if we're looking at how much a person earns in a week, that may be dependent on how many hours they work. Okay, so those two variables may be dependent on each other. And if we don't account for that in our model, when we start analyzing, we could get some false results because those are going to be dependent in our sample. Independent means there's not going to be any connection. So that means that how much money a person earns in a week is not going to be connected to what they ate for breakfast. Those are totally independent. You want your observations to be independent of each other in certain tests that you're doing. If they're going to be dependent on each other, then you're going to have to account for that and make some statistical adjustments to be able to explain that and not get false information. You're going to look at the assumptions, basically the two assumptions for the independence. Observations between groups should be independent. And that means that your individuals and your groups should be independent of each other. You can't have one individual in both groups because that's going to skew those results. Observations within each group must be independent. So if there are two more data points in one group are connected in some way, again, then that's going to skew it. And the example I put here was if you're going to take a snapshot of how many donuts office workers eat, and you count at 9 a.m., 10 a.m., and 11 a.m., and then you say, well, office workers are taking 25% of their calories from donuts because of what you did at 9, 10, and 11, those are not necessarily going to be independent of each other because you captured the data in 3 different points when we would primarily be eating breakfast. If you wanted to capture the points at breakfast, lunch, and dinner, those are going to be more likely to be independent of each other. So this can be a little cloudy sometimes, but it's things you have to think about, and you think about it when you're designing your methodology. But then after you collect your data, you're going to have to run some statistical tests to clean that up to see if you have a dependency or not. And then if you do, you're going to have to make a decision on what to do about it and how to explain it. If you do violate that assumption of independence, then you're going to run the risk of all your results being wrong. So that's something that's real important for you to look at is the independence of your variables. Normality of data, again, that goes to that bell curve. And if the distribution is normal, there's an assumption in these theoretical distributions that the data is going to have some normality to it. And there's not going to be any kurtosis where it's skewed one way or the other. We're not going to have normal data. We just don't. It just doesn't work that way. We hope it gets as close as possible, but we're just not going to. So again, depending on how much it's skewed, we have to make a decision. Are we going to have to do some type of statistical intervention to bring this back into normality, or is it going to be okay to violate this assumption to a certain level? It will weaken some of your results, but it doesn't compromise them all. And some of the statistical tests that we run, it'll say that this particular like independence t-test can be very robust for non-normal data. But these are things that you have to consider again when you're cleaning up your data. Even if you don't do anything to change what the data looks like in terms of that normality, you have to make some explanations about it in your results. The homoscedasticity, that refers to the residuals in the regression. And again, this is primarily for multiple regression, being equally distributed or whether they're going to actually be clustered around one part or another. So the opposite of homoscedasticity is heteroscedasticity. And you really want homoscedasticity and not heteroscedasticity. And this may get a little clearer when we look at it, but this is a particular box plot that you do to determine if you've got homoscedasticity, which is the first one, and you can see it's kind of like a shotgun blast. And so everything's kind of equally distributed around there, where if you have not homoscedasticity, then they're going to be clustered in different areas. Then you have to decide, is this going to impact my analysis? And if it is, what am I going to do about it? And again, there's some statistical interventions that you can do to help alleviate or eliminate some of the compromises that this may that this may have on your data. And linearity, which is relevant for multiple regression. That was where your predictor variables regress in a straight line, the relationship to the outcome variable. If you have multicollinearity, then your predictor variables are highly correlated with each other. And it's going to be difficult for your statistical analysis to say which one is contributing more to your outcome variable. Multicollinearity actually comes out in terms of this variance of inflation factors. And these are the things I want to be able to put in here and show you how to run in SPSS, so you'll be able to see that. And then you want your values to be below 10, so it'll tell you if you have multicollinearity or not. But this is just a brief overview, again, of cleaning up your data and some things that you're going to have to consider after you collect your data. You're going to go through each one of these and you're going to address each one of these in terms of your results. Any questions? Or y'all just got all that down?
I have a quick question.
Okay.
Just since you kind of ended on regression there, we are going to be going into regression models specifically, right?
Yes, yes.
Okay. Okay.
Yes, we will. It's set up so we're going to do the correlation and the simple regression next week, and then we'll go into multiple regression the next week. Okay. So no matter what statistical analysis you're going to do, each of you will go through this cleaning process with your data after you get it. Okay. Some of it might not apply depending on what statistical test you're going to run, but you're going to have to, and literally what I do is I just start with missing data. I look through it, explain it. I look at my outliers. I go to normality. I just go one by one systematically and go through each of those to determine if I have any problems or not. Okay. Because you're going to want to explain that in your results, what you did, what you identified, what you didn't identify, and all of that in terms of cleaning up that data. That's the first thing you do when you have your data is just, and when they talk about cleaning it up, that's what they talk about, is going through and doing all of that.
Okay. Thank you.
Okay. And then you'll start running your analysis. Other questions about that? It'll make more sense as you go through and take some time to really look at those. And again, I'll put some examples up there so you can see how to go through and clean the data, how to run box plots, scatter plots, because a lot of it's visual, and using those graphs in SPSS can help you determine if you have a problem or not.
I actually have a question, Dr. Judd. I started working on homework 2, and I've noticed that this class today it's a lot of it's integrated in the last question of the homework. And so for homework 2, are you I know that I think it was your 3rd slide that had specific things that are a specific checklist for models of assumptions. So I guess for the last question, you're expecting us to go through every single one of those items.
See if they apply.
Okay. Okay.
Yeah, do that and see if they apply to that. Okay.
Yes, that's fine. And so when I was looking through the question, something kind of caught my eye on the SPSS file that you provided to us. There is a 3rd variable on that file, and that is budget. And I guess I couldn't make my mind. I couldn't quite figure it out if that was a variable that needed to be put into place within what we're looking for.
Okay. So let's talk it through. So will it, if you include budget, is it going to help explain your results? Is it necessary?
Well, I don't think so, because they're just trying to look if the sales will increase given the amount of, I guess, publicity they put into the band's image. and or how many times it plays in the radio. So I'm just assuming that budget will be a contingency of how they will approach after the fact, if they see if there's anything that might change, or if there's any variable that they believe it's more more, I guess, stronger, and that will be when they will make specific, I guess, an assumption of we're only going to put budget on Ben's image, for example. So
Okay.
I'm assuming, yeah, go ahead.
And that is absolutely one way to look at that it could be a contingency variable. You could also take it and determine budget, what potentially may cost more, may not cost more. And again, doing the same thing you've talked about in terms of how they might invest the money. So once you have the results, you may want to take that a step farther and then indicate how budget would impact those results.
Okay. Okay.
I guess to say there's not a true, I don't know that there's going to be a true absolute right or wrong answer to that. It's going to be dependent on how you take that question and that data and then make that determination, and how in depth you want to take it and how many assumptions you want to use there.
Okay. And I'm so sorry to ask, I guess, one more question. But when, so I did the test of normality, and then I was doing the homogeneity of variance, and so much data popped up. It took like 5 minutes for my computer to load. A whole lot of graphs just kind of popped up, and then I tried other methods, but still a whole lot popped up. Do you know if there's a specific, like, how do we do data cleaning in SPSS?
And that's what I want to be able to do, and be able to do screenshots for you to do that, instead of just writing an explanation. So I'm going to add that into this if I can get my SPSS tomorrow. Okay. And again, because I've done it for so long in Excel, I've got to go back and refresh my mind on the new SPSS in terms of how to do that. But I will provide that for you, so that you'll have a straightforward way for each of these areas on the cleaning part of what to run in there.
Perfect. And yes, that's perfect. And I'm so sorry, one last question.
No, fine. Go ahead.
Do you intend for us to do data cleaning on that sample as well?
It would be great practice.
Okay, that's fine.
Mm-hmm. Yeah, it would be great practice to do that. Yeah. Okay. Yeah, so let's say yes.
Perfect. Thank you so much.
All right, well, thank you. Other questions at this point? So how many of you have an idea of what you're wanting to do, the topic area for your dissertation? A couple of you in that part. So as you're going through and trying to determine that, and you're reading the literature, you're reading studies, pay attention to the measurement tools that they're using. Pay attention to their methodologies. I like to say you don't have to reinvent the wheel. When you see somebody doing something and you think it's a feasible methodology for you to do, then you can use that information to build yours. So you're not having to sit in a vacuum by yourself and then determine what you need to do. You get those ideas from what other people's done too, and you may combine 2 or 3 different methodology studies, and different tools, something like that. But that's what you should be really looking for when you're reading that literature, to help inform how to draft your actual research project, if that helps. Other questions? I'll get the SPSS part of the cleaning up done tomorrow and get it posted for you. So you'll have those going forward. And there was something else I wanted to go over with y'all tonight, and I totally forgot what it was. I should have wrote it down. I posted the one about the null hypothesis testing, about hypothesis testing overall. We always test the null hypothesis. That's the one that we're actually testing. Our alternative or our research hypothesis is what we typically are interested in, but we're always testing the null hypothesis. And then I talked a little bit about effect size on there too. And that was the other thing I needed the SPSS for, to show y'all how to run the statistics to determine effect size. That's something that you're going to do before your data collection when you're writing your proposal, is you're going to need to determine the sample size, the best sample size for you to get the effect size that you need in terms of your significant results, because you're going to have specific sample sizes depending upon how many dependent variables you have, independent variables, and all of that. So I'll get the SPSS part of that too for you, so you'll know how to run that.
I have a general question, and looking at the syllabus that I didn't notice last time. Do you know what, I don't see a due date for our assignment where we compare the two types of articles. Am I missing that, everybody, or?
Let me pull that real quick.
There's no due date listed, and also homework number 4 is not listed. Homework number 1, number 4 are missing. The due date for the paper are missing.
Okay, so homework number 2 is due like on the 28th. Number 3 is due like on March 21st. Homework number 5 is due on April 18th. Oh, did I miss that in here? You're right. And you know what? I've got it in, I have the due date inside the D2L, and I need to look at it to make sure that I don't give you the wrong one. Because I did not include that on the syllabus. I apologize for that. Thank you for catching that. Towards the end of the semester.
I saw that in D2L, it says that the exploratory factor analysis article, it's due on April 11th.
Thank you.
But there is no mentioning of the homework 4. I think that's the only one missing.
Okay, so April 11th for the articles. And then I missed the date for homework 4, right? So let me review that and I'll get that clarified for you. Okay. So homework number 1 will be due this next Sunday night, the 31st. I've made it, everything is always due on Sunday night. So just remember, if the dates will always be on Sunday night, that'll be consistent for you. So it's due on the 31st. And then the second one is not due until February 28th. So you have time on it. And then the third one is due March 21st. And then the fourth one is going to be due sometime between March 21st and April 18th, but I got to go back and look and make sure I have the correct date for you, okay? So I will do that. Other questions? So we'll do the cleaning. I'll have this up for you so you can look at how to clean and go through SPSS. And then next week, and I'll have this up early also too, we'll look at correlation and simple regression. Okay? So we'll start actually getting into the statistical analysis part. Have y'all been given a decision tree on to know when to run which test for which variables and things? Would you think that would be beneficial? There's different ones out there. So it's like if you have one variable, two variable, one group, two group, it's kind of a decision tree for you. Okay. And then that'll be something that you can use as you're developing your dissertation also to know what your analysis is based on the methodology that you'll be using there.
Dr. Judd, had you made any decisions on an SPSS tutorial or?
Yes, I'm going to put one together, but I have to get my SPSS license to be able to do that. And like I said, if the university doesn't get it to me, I'm just going to use the one I'm just going to purchase the one y'all are using, but I will do the tutorial on it. And I think it'll be best if I do short tutorials for different things. And then you can always go back and pull those up as you need them, okay? Just for the different components to it, okay? But yeah, I've got to get the SPSS license. Like I said, I had no idea that it even expired and didn't renew till I got ready to use it. Anything else? Y'all all good?
For our final presentation, it's any of the statistics that we've covered in this class, right?
Yes, ma'am.
Okay.
Mm-hmm. Yeah, I would, yes, it can be any of the statistics that you've covered in the class. I would encourage you to pull the most difficult one, simply because teaching it, you learn it. So I would encourage you, the one that you have the most difficult time with, that's what I would encourage you to present. But it can be any of them. Anything else? Is that all? Good. Everybody's class is going good? Good deal. Good deal. Well, I'll get this presentation finished up, and my goal is to get it uploaded tomorrow so you'll have access to it. And my goal is to get the SPSS tutorials, get those started and get those in there. We can just go from there. That work? All right. Y'all have a good evening.
Thank you. You too.
Thank you, you too.
Bye.